Hi students, the last one we've made it, lesson 12, video I. We've worked with normal models, we've computed percentiles and probabilities and proportions, we've converted from z-scores back to the y variable and all kinds of problems, and we'll practice in class. In video I, here's the deal. We have data that we've collected. Say we've run a survey of Cecil College students and determine their age or their weights or their heights or their IQs or something. We would like to know if a normal model is appropriate for that data. What you have to do is graph. Okay? This is not an exact science. This is more subjective than some of our other techniques. Bullet point, checking data for normality, that's the topic. It might be tempting to assume that a normal model almost always applies to data. That is certainly not the case. You'll see in all my examples that I think we have one normal model and 5 that are not normal. Okay? How do we use StatCrunch to determine if a normal model is appropriate for a variable? So I'll show you some pre-made graphs for variables that are in StatCrunch, and then in class we'll practice the techniques on the computer. Step 1, make a histogram. We've been making histograms for probably 6 to 10 weeks by now in the course. What do the data need to look like in the histogram? Unimodal, symmetric, and very minimal outlier effect. Okay, so the data must be unimodal. That means one major peak. Symmetric means that the peak will be in the middle. And of course, we would call that bell-shaped. Right? So the data needs to look bell-shaped. Okay? Now, sometimes things are hidden in a histogram. Believe it or not, you might have too much data piled up in the center or too much data piled up in the tails, even though it looks pretty darn normal. So there's a second plot that we need to check in conjunction with the histogram. You have to use both and sort of make your best judgment using the clues from both graphs. That graph is abbreviated as a QQ plot. QQ stands for quantile quantile. In this plot, you'll see a bunch of dots. The goal is for the dots to fall very close to the straight diagonal line. Okay? If the points are generally straight, and if the points generally fall close to the diagonal line, then normality is plausible. Be careful, a QQ plot is not a scatter plot, so don't interpret it like a scatter plot. We're not looking for form, we're not looking for strength or direction. Okay? This plot is specifically designed to check data for normality. Okay, and it's a bit technical at the intro stat level as to why this plot works. If you look at the bottom of the page, I wrote a footnote that's about a 300-word essay in terms of why the plot works. So for the video, we'll leave it at that, and in class we might talk about it for a moment or so. A couple of examples. I bowled in a men's league a few years ago. Of course, as a statistician might be apt to do, I got home and entered my data into StatCrunch every week on Tuesday night, try to see how, if I'm improving over time, what my mean average bowling score is, etc. So here's the histogram. This histogram is not symmetric. It's certainly unimodal. If you tried to smooth this out with a curve, it's unimodal. There's one major peak somewhere in here, around 180, 170 or something. But it's skewed. So this data is certainly skewed. If you could only look at the histogram and you had to make a judgment, you would say, no, my bowling scores for that league were not normal, right? They're not bell-shaped. Skewed, this is certainly not normal looking. There are other models. You'd learn about them in a Stat 2 course or even a more advanced course that could handle skewed data like this. But in Intro Stat, there's only so many hours in the course, so we stick with normal. Over here's that quantile plot. Typically, these plots will put a diagonal line on to help you gauge it, but there is a fairly wavy pattern to this, and the wavier and curvier this gets, it's more and more evidence that a normal model is not appropriate. So this is just an eyeball test. You have to use your best judgment. Would you be comfortable modeling these data with a normal model? Are the clues from this QQ plot telling me that it's normal? This is too wavy for me to be comfortable to say use a normal model, and that's supported by the shape of this histogram. Right? So just eyeball test. This is not straight enough. Remember the point of this graph, it's not a scatter plot, it's to measure the plausibility of normality. Okay? Too much waviness. And overall assessment, I would not use a normal model to model my bowling scores. Okay? Just wouldn't do a good job. All right, so we'll move on here. I've mentioned it, but I'll say it again because it's important. You've got to look at both graphs. You've got to look at histogram in conjunction with the QQ plot. Certain things could be hidden in the histogram that will come to fruition when you look at that QQ plot. Too much data piled up in the center, too heavy tails. Always check both graphs. Okay? One more comment. With small data sets, say you collect a data set and you have 11 values, 8 values, 13 values. It's very difficult to determine with small data sets whether or not a normal model is appropriate. Okay? For one, the histogram, think of how histograms are built. The more data that you have, the better you'll be able to see the clear pattern and the shape. If you only have 8 data points, try building a histogram from that. Right? You won't be able to make a good assessment. So use common sense. Always try to collect enough data to make a fair judgment. All right, I guess it looks like what? 1, 2, 3, 4 quick examples. Gas prices from 8 states were recorded over a period of months a few years back. Based on these graphs, is a normal model appropriate? All right, number 1. Here's the histogram. If you did a quick eyeball test over here on the histogram, you might say, you know what? It's pretty unimodal. It's pretty symmetric. And you might say, well, possibly a normal model, right? But when you look at this quantile plot over here, the QQ plot, things are pretty good here. There's a little bit of a general pattern that's coming off, and then you've got this big curvy part. And what this is this data around the $4.10, $4.20 that's piling up. And what they're saying is there's too much data up in this upper tail. We wouldn't expect this much data in the normal model. That's why you're seeing all these dots sort of come off the line. And again, a quick eyeball test here, you might say, you know what, I'll go with the normal model, but I think this is probably not the best idea. QQ plot, this is concerning, and so overall assessment is I wouldn't feel terribly comfortable using a normal model. Normal model, here, not the best idea. Don't want you to feel like you have to model things with normal models. Okay? Moving on, 1 down, 3 more to go. Here's carbs, 1 at the bottom of the page there. Carbs for chicken sandwiches. So I think these all came from fast food restaurants, Burger King, Chick-fil-A, etc. Carb count, we see a big pile up around 40 to 50 grams. This is your, typical normal looking histogram. Smooth curve, we're feeling pretty good about this. I checked this off, and the check means that I'm pretty comfortable that a normal model would do a good job. Over here, the general pattern is fairly straight. You might be a little bit concerned with a few outliers. When you're looking at these quantile plots, you'll almost always have a little something funky going on. Remember, students, a model is a generalization. When you have data, you're never going to be able to model your data perfectly. Okay? So in this case, based on the clues, I would feel comfortable modeling with a normal model. I understand the model's never going to be perfect, but based on the data, this is sort of good enough to satisfy me. So I feel comfortable here with normal model. All right. And again, the model won't be perfect, so you can see that. Okay. 2 more, we'll flip the page. I threw in one where it was just so far off the mark that nobody would ever come to the conclusion that this is normal. Back in fall semester, Cecil students reported a number of texts that they sent and received during a typical month or the previous month. Would you use a normal model? Of course not. This is super skewed, right? This is very skewed right. most students are texting, I guess, between 0 and 2,500 texts per month, and you've got some upwards 15, 10, 20,000 texts in a previous month. Super skewed right. I don't even need to check that quantile plot, but I did. Look how far this is. Don't get confused just because this is fairly straight here. We're trying to get this to match up on the diagonal line. The closer the points are to the diagonal line, the more likely a normal model is the right model. This is so far off, right? Big X here, big X over there. There are models. An exponential model, which we don't learn about in this course, would model this data very accurately, okay? But not a normal model. There's no gray area here. Everybody says not normal, then you get your points. All right, last one. A little tricky one here. If we think back a few years, there was the major earthquake in Japan, the Honshu earthquake. The data set has every earthquake that was recorded about a week surrounding the big one. And what we're looking at is the depth. So all those recording stations in Japan were recording the baby earthquakes that led up to the big one and the aftershocks that came after it. And this is the depth, probably in kilometers, of where the center of the earthquake originated. And all these earthquakes, no matter how small, were recorded by, I don't know what an earthquake scientist is formally called, so by earthquake scientists. And would you say normal? And the point of this one is, even if you're willing to say, well, I can sort of knock out these high outliers and just look at this picture, it's like unimodal and symmetric, and I'll disregard these couple of outliers, and I'll say that a normal model will fit the bill here. Okay? When I go to the QQ plot, we're looking for a general straight pattern. You can see up here, these are the few outliers that I've circled. That being said, it's so misleading, right? You look at this, you say normal model, well, I've got it, but you have to look at both pictures. This tells me that there's way too much data either piled up in the center, there's not enough data off-center to the right a bit, and you're getting this very distinct, not straight pattern. So because this is not straight, who cares about the 2 big outliers or 3 big outliers? Even though it's unimodal and symmetric, it's not normal. Okay? Have to use both graphs in conjunction. Overall assessment, not normal. All right. In class, what we'll do, we'll pull up a bunch of data sets. We'll let students pick, make the graphs, and try to make assessments. Okay. Don't worry too much. Sometimes you'll get ones that are in the gray area, and as long as you can defend your choice and refer back to the histograms and QQ plots and interpret those properly, the ones in the gray area, sometimes 2 different people might make different assessments. Here it's clear-cut, the 2 on the last page. Everybody should make the same decision. All right, so that does wrap up the normal model lesson. We'll see you in class. Thanks for watching.